So, artificial intelligence, it feels like it's everywhere, right? The headlines are just nonstop, promising us everything from AI doctors that are better than humans to machines that are about to wake up. But what's really happening under the hood? Beyond all the hype. Okay, let's really get into it and try to separate what's truly incredible from what's still science fiction. And don't get me wrong, the reality is absolutely incredible. I mean, when Microsoft researchers got an early look at GPT-4 and published a paper calling it Sparks of Artificial General Intelligence, that really got people talking. They were basically saying, whoa, we might be seeing the very first glimmers of a true general intelligence here. And honestly, you can see why they'd think that. And that right there, that's the million-dollar question, isn't it? It's really the heart of what we're talking about today. When a machine can do something just as well as a person, or maybe even better, does that mean it actually understands what it's doing, or is it just a brilliant imitation? This is the one question we have to figure out to really get what AI is and what it isn't. Now, before we start poking holes in things, we have to give credit where it's due. The things AI has accomplished are genuinely mind-blowing. We're talking about some of the biggest engineering achievements of our time. So let's just take a quick look back at some of the greatest hits. Just think about how this has escalated. Back in '97, IBM's Deep Blue beat the world's best chess player, a huge feat of strategy. Then, a little over a decade later, Watson comes along and crushes the best human players at Jeopardy, which is all about language and obscure knowledge. Then, in 2016, AlphaGo masters Go, a game so complex it makes chess look simple. And now, we've got GPT-4 passing the bar exam for lawyers. These are just monumental wins in these very specific, well-defined areas. So yeah, AI is a powerhouse, no doubt about it. But, and this is a big but, this is where the story gets a lot more complicated. As amazing as those victories are, they also kind of hide what's really going on. So let's pop the hood and see the fundamental limits at its core. Okay, so here's the most important thing to get your head around. These AIs, especially the big language models, they aren't thinking like you and I do. They are just unbelievably good at matching patterns. They've seen basically the entire internet, so they've become masters at predicting what word or pixel is most likely to come next. It's like a superpowered autocomplete. It's mimicry, not real understanding. And that leads to the second big limit. An AI's whole world is just the data it was trained on. That's it. Imagine someone who has read every single book in a giant library, but has never, ever stepped outside the building. They can connect ideas from all those books in brilliant ways, but ask them about something completely new, something not in any of those books, and they've got nothing. They just can't. Right, and because they only know data, they have no real-world experience. An AI doesn't have a body, it doesn't have senses. It can process the word heavy 1,000,000 times, but it has never felt the muscle strain of lifting a heavy box. It can write a poem about rain, but it has never actually felt a single drop on its skin. And without that physical grounding, it can't have common sense. That gut feeling we all have about how the world works. All right, so enough with the theory. Let's see what happens when these limits show up in the real world, because this is where it gets really fascinating. The failures are actually just as revealing as all the big wins. Get this. Someone gave this little riddle to IBM's Watson. Yep, the same genius AI that won Jeopardy. And Watson couldn't solve it. A kid could figure this out in a few seconds. So why did Watson fail? Well, because a kid uses basic logic. Watson was just scanning its massive database for patterns about foos and bars, and since it found none, it was totally lost. And that silly riddle just perfectly shows the difference between how we reason and how an AI reasons. We build these little mental models of the world to solve new problems, but the AI is just hunting for patterns it's seen before. If the problem is totally new and doesn't match an existing pattern, the AI can break down completely. It's surprisingly fragile. Here's another wild example. It's something called an adversarial input. Researchers found you can take a picture, say of a school bus, that an AI is 100% sure is a school bus. Then you change just a few pixels in ways a human can't even see. And suddenly, the AI is 100% sure that same picture is an ostrich. Seriously. It just proves its knowledge isn't deep or robust like ours. It's based on finding statistical shortcuts that are actually pretty easy to fool. You know what's really crazy, though? This whole debate, the difference between acting smart and being smart, it's not new at all. We're not the first people to be scratching our heads about this. Philosophers have been chewing on this for hundreds of years.
I mean, go all the way back to 1637. The philosopher René Descartes basically said that for a machine to be truly intelligent, it would have to use language creatively and solve all sorts of different problems, not just one. Then fast forward a few hundred years to Alan Turing, who famously shifts the goalposts. His test isn't about thinking, it's about acting so human-like that you can't tell it's a machine. And today, the question has changed again. We're not just asking, can it think? We're asking, what kind of intelligence are we even trying to build here?
And this table is a great way to think about that. You can basically break down the goals for AI into 4 camps. You could try to build a system that thinks like a human, or one that just acts like a human. Or you could aim for something that thinks or acts perfectly rationally, like a flawless logician. And if you look closely, you'll see that most of the successful AI we have today is really focused on that bottom right box, systems that act rationally to get a job done. There's no requirement that they have to think like us or even understand what they're doing. So, after looking at the amazing wins, the surprising limits, and the long history of this debate, what's the takeaway? What's the right way to think about AI right now? Let's try and pull all these threads together. I think the clearest, most honest way to see AI today is as a tool. Simple as that. Now, it might just be the most powerful intellectual tool humanity has ever created. It's this incredible engine for finding patterns and amounts of data that we can't even comprehend. But it's not a mind. It doesn't understand things, it isn't conscious, and it doesn't know anything in the way that we do. It just puts on a really, really convincing show. And that leaves us with one final and really important thought. Understanding what AI can't do isn't about tearing it down. It's about using it smartly. Because when we know what it is and what it isn't, we can finally ask the right question, which is, how do we steer this incredibly powerful tool in a direction that truly helps all of us? That's the real challenge ahead.